next we have the calculation of number of geometrical isomers, which is equal to the number of possible pairs, and there were only two possible pairs for MA3B3, FAC isomer and the MER isomer. So there are two geometrical isomers, that is, one of them is the facial isomer, the other one is the meridional isomer. Next we have optically number of optical isomers. So number of geometrical isomers is 2. The number of optical isomers is 0 because there were no optically active pairs. And because the number of optical isomers was 0, so the number of enantiomeric pairs is also going to be 0. So 2, 0, 0. Next we have the number of stereoisomers. So let's fill in the details. You already know 2, 0, 0. The number of stereoisomers is equal to the number of optical isomers plus the number of optically inactive pairs. So that's 0 plus 2, which is equal to 2. Next we come on to the complexes of the type MA4B2. So there are two types of ligands present. First of all, 4 times A and 2 times B, which is giving it an overall coordination number of 6. This is the first possible pair in this A is trans to B, A is trans to B, A is trans to A. So in this case, the trans pair is getting repeated as well as the same ligand is trans to each other. So this is optically inactive pair. Now let's go to the next possible pair. In this, A is trans to A, B is trans to B and A is trans to A. In this case also this trans pair is getting repeated as well as the same ligands are trans to each other. So this is also optically inactive. So these are the only two possible pairs for the complex MA4B2. So next we will see the number of geometrical isomers, optical isomers, stereoisomers and your enantiomeric pairs. Number of geometrical isomers is equal to the number of possible pairs, which were just 2. Number of optical isomers will be equal to 0 because there were no optically active pairs. So this is 2 and this will be 0. So 2, 0, and the number of enantiomeric pairs is equal to the number of optical isomers divided by 2. So number of enantiomeric pairs is also 0. Last of all, you have the total number of stereoisomers. So first fill in the details. Okay. Now total number of stereoisomers is equal to the number of optical isomers plus optically inactive pair. So optical isomers 0, optically inactive pairs 2. So total number of stereoisomers is 2. So this were the total calculations for the complex MA4B2, that is, it has 2 geometrical isomers, no optical isomers, no enantiomeric pairs, and it has 2 stereoisomers in total.